Hello to everyone, I am Dr. Karunesh Srivastava from EC Department of Ajay Kumar Garg Engineering College, Ghaziabad. So, today I am going to discuss about the modeling of the system. In the previous lecture, I have discussed about the block diagram reduction method, and I have discussed one more example related to the block diagram reduction. So, in the control system, this is a block diagram reduction is the important topic, and signal flow graph is also the important topic. And by using signal flow graph, we can also reduce, we can with the help of signal flow graph, we can make the, we can reduce, we can find the transfer function, or from the block diagram we can change the block diagram into the signal flow graph, and after that we can calculate easily the transfer function using Mason's gain formula. So, in this lecture I am going to discuss about the modeling of the system, in which I will discuss how will I make the voltage analogy of any given mechanical system. So, before moving to that topic, we should know the basics of mechanical system and how the force and torques are calculated for any mechanical system. So, first of all, I will discuss the basics related to the mechanical system. After that, I will come to the electrical system. After that, I will draw the analogy of the mechanical voltage analogy or current analogy of a mechanical system. So, what is modeling of the system? Modeling of a physical system. Modeling is element or mathematical representation of system or a plant, or you can say you can represent any system with the mathematical representation. The control system can be represented with a set of mathematical equations known as mathematical model. So, in this control system, we know that whenever we are finding the transfer function, it means we are finding the output to the input ratio by taking all initial conditions 0. So, in the mathematical modeling, we have to find the differential equation. After that, we can find the transfer function, and with that model we can also draw the state space model for a given system. So, whenever we are finding the transfer function, we are discussing we are discussing about the S domain. We are interested only in S domain math. So, in the dynamics in Laplace transform expression and representation is done in frequency domain for finding the transfer function model, and in differential equation dynamic in terms of differential equations are represented in time in the time domain, or you can say whenever we are representing the system, we are writing this in a differential equation form in time domain, and whenever we want to represent the system in frequency domain, we are writing this in Laplace transform. We are finding the Laplace transform of the system. So, in modeling of electrical system, these are the basic elements. Resistor, the symbol used for resistance is this, and the voltage across this resistance is nothing but the current flowing through this resistance is IT. Then the voltage across this resistance will be V is equal to IR, VRT is equal to IRT into R, and in S domain we can write VRS is equal to IRS into R. So, this is nothing but we have represented this in S domain. I have replaced this T with the help of by S. Capacitor. Capacitor is a charge storing device, and voltage across capacitor can be found using this formula. VCT is equal to 1 by if the current flowing through this is ICT, then voltage across this capacitor will be VCT is equal to 1 by C integration of ICT dt. If we want to represent this voltage in S domain, then VCS is equal to 1 by CS into ICS. So, here we have considered that there is no charge stored in the capacitor. So, otherwise we have to consider the initial conditions also. So, this is the another element, basic element of electrical system. Another element is inductor. So, the inductor is energy storing device. The time domain expression relating the voltage and current for the inductor is given as V is equal to L dIL by dt. Voltage and current is a function of time, and if I want to represent this into S domain, then this voltage across this capacitor is voltage across this inductor in S domain will be equal to VLS is equal to LS into ILS. We have to use the differentiation and integration property of the Laplace transform. So, here in the capacitor 1 by Cs into Is, and in case of inductor 1 Ls into ILS. Now, coming to this analysis of electrical system, this is the basically whenever we are finding the voltage and current, we are basically using the nodal analysis or mesh analysis for finding the voltage and current for a given system. So, this is the mesh, this is the mesh or network, and this is also the another in which you can see that resistance, inductor and capacitor are connected in parallel, and here in this circuit voltage, current, resistance, inductor and capacitors are connected in series. So, if I want to find the current flowing through in this branch, a total current in terms of inductor, capacitor and resistance, we know in terms of voltage. So, we know that whenever the branches are connected in parallel, the voltage across that branch will be same as voltage across all the branches which are connected in parallel will be same. So, we can consider here the voltage across all the branches connected in parallel is V, because how we can say that the voltage across all the parallel branches will be same? The condition is that no element should be connected in between that branches. So, it is clear that no branches are connected in between the parallel branches, therefore, we can say that the voltage across all the branches connected in parallel will be same. So, now we can apply here KCL, Kirchhoff's current law. Incoming current is equal to outgoing current. So, at this node we can say that I is equal to IR plus IL plus IC, where IR is the current flowing through the resistance, IL is the current flowing through the inductor, and IC is the current flowing through the capacitor. So, we know that the current, if the voltage across this branch is V, so what will be the current flowing through this resistance? We know that Ohm's law, V is equal to IR, so I will be equal to voltage divided by this resistance, I is equal to V by R. Now, the voltage across the inductor, so I have already told you that what is the voltage across the inductor? V is equal to L di by dt. So, how can we find the value of I? I is nothing but V by L integration of V by L if I integrate V dt is equal to L I. So, I is equal to 1 by L integration of V dt. Similarly, we can find IC is equal to, what will be the IC? IC is equal to C dV by dt. We know the relation, I is equal to C dV by dt, or you have already studied Q is equal to CV. So, Q is nothing but dQ by dt is nothing but I. So, you can write here I is equal to C dV by dt. So, using these formulas we can get the current flowing through the current flowing through the resistance, inductance and capacitance. So, we can write this equation. but we also know that in terms of flux, V is nothing but d phi by dt. So, what will be the value of I? I is nothing but c d square phi by dt square. I am putting here V is equal to d phi by dt. So, I will get here c d square phi by dt square plus 1 by r d phi by dt plus 1 by L integration of V dt is nothing but phi from this equation. So, say this is equation 1. Now, you can see here these components are connected in, these elements are connected in series. So, the current flowing through each branch will be current flowing through each element will be same. So, suppose the current flowing through this branch is I. So, what will be the voltage? V is equal to voltage across this element, voltage across this element and voltage across this element. So, what will I get? V is equal to VR plus VL plus VC. V is equal to IR plus L di by dt plus 1 by C integration of I dt, 1 by C integration of I dt. V is equal to IR plus L di by dt plus 1 by C integration of I dt. Similarly, we can write here, we know that I is equal to dq by dt. So, we can write here L d square q by dt square plus R dq by dt plus q by C. So, this is the another differential equation for this network. So, we have seen this, there are these two, when the components are connected in parallel and series, we are getting these two equations. We will try to draw, we will use these equations for getting the mechanical equivalent of electrical equivalent of mechanical system, because we want to draw a electrical system from a given mechanical system. So, what is the reason why we want to draw this? Because the mechanical elements are costlier as compared to these components connected in circuit. So, I have already discussed this, what is the relation, voltage and current relation between resistor, capacitor and inductor. So, you have seen this, V is equal to IR and I is equal to V by R. V is equal to 1 by C integration of IC t dt. So, IC t d is equal to C dV by dt, V is equal to L di by dt. So, I is equal to 1 by L integration of VL t dt. Now, coming to the modeling of mechanical system. So, in case of translational system, basic elements are mass element, damping element or damper and spring element. So, mechanical system, basically mechanical systems are classified into two parts, that is translational mechanical system and rotational mechanical system. In translational mechanical system, we are talking about only the linear system, or you can say we are talking about the linear motion, or you can say that these are the we are talking about the only linear motion. And in rotational system, we are talking about the angular motion or angular movement. So, basic elements in translational system or translation mechanical system are mass element, damper element and spring element. But in case of rotational system, the basic elements are inertia, damper and torsional spring. So, what will be the input in case of translational system and what will be the output, and what will be the input and output in case of rotational system. So, the input is, in case of translational system, the input is force and output is displacement. So, whenever you are applying a force to any mechanical system, there is some displacement and that is the required output for a given translational mechanical system. But in case of rotational system, the input is torque and output is angular movement, angular displacement. Similarly, we can say that this is the linear displacement, or you can say this is the linear velocity, and this is the angular displacement. So, there will be some angular velocity. So, whenever we are discussing this linear translation system or mechanical translation system or mechanical rotational system, we should be very clear that whenever we are finding the transfer function, the output and input should be known. If the input is known and the output is known, then we can easily find the transfer function of any given system. Now, coming to the basic elements of the mechanical system. So, first basic element is mass. Mass is the property of a body which stores kinetic energy due to the translational motion. If a force is applied on a body having mass m, then it is opposed by opposing the force due to the mass. So, this force is nothing but m into a, where a is acceleration and m is the mass. So, and we can write this in terms of displacement, and we can also write this in terms of velocity. So, this force is nothing but mass into acceleration, and this is equal to mass into d square m into d square x by dt square, or you can say that this is m into dv by dt. Next is inertial mass in case of rotational system. So, this is nothing but same, we can replace, you have already studied the mechanical system. So, I am not going in deep to this mechanical system, I am discussing only the force and equation for force and torque. So, you know that the torque is nothing but inertia j into d square theta by dt square. This is already written here. This is nothing but j d omega by dt. So, this is angular displacement, this is angular velocity. J is nothing but, if we replace this in linear translation system, this is nothing but mass. Now, next element is spring. So, this is a spring for the linear translation system. If I apply a force F, then there will be some displacement x, then what will be the value of force F? Force F is nothing but k multiplied by x, where k is the stiffness of the string. F is F is equal to kx. Next is for rotational system. Again, torque is equal to k into theta. K is the stiffness of the spring and theta is the angular movement. Damping element, F is equal to damping element having the damping coefficient beta. So, force is equal to B into dx by dt, or force is equal to B into V. B into dx by dt. Now, this is all about the rotational system. This is for the torque for the rotational system. T is equal to B into omega B into d theta by dt. B into d theta by dt, where B is damping coefficient and omega is the angular velocity and theta is the angular displacement. Now, this is I have discussed all the basic elements related to the electrical system and mechanical system. Now, I am going to draw the electric. I want to find the mechanical equivalent of the electrical component. What component will be equal to the mass element in electrical system? What will be the equal to the damping element in case of electrical system? What will be the equal to the stiffness of the spring in electrical system? Now suppose I have already seen that we have considered two networks parallel and series network. So I have already written an equation for this network. I is equal to IR, IL, IC. I is equal to IR plus IL plus IC. IR is nothing but voltage across each branch is V. So we have written here V by R. I have already told you that V is equal to L di by dt and Q is equal to C dV by dt. So we can write here I is equal to in terms of voltage, if you want to write here, you can write here I dq by I is equal to dq by dt. So we can write here sorry, Q is equal to CV. I is equal to dq by dt, so you can write here I is equal to C dV by dt. So we can write here V is equal to L di by dt. So what will be the value of I? I is equal to 1 by L integration of V dt. So we can write here 1 by L integration of V dt. IC is nothing but C dV by dt. So we can write this equation, we can we know this. What is the relation between voltage and phase? V is equal to voltage and flux. V is equal to d phi by dt. So we can write here C d square phi by dt square plus 1 by R d phi by dt plus phi by L. So this is the equation for this. Say this is equation 1. Similarly, L R C. So V is equal to VR plus VR. We have already discussed this. V is equal to IR plus L di by dt. Q is equal to CV. So V is equal to C dV by dt. So V is equal to 1 by C integration of I dt. So we know this I is equal to dq by dt. So we can write here L d square I by dt square plus R dq by dt plus 1 by C integration of I dt is nothing but Q. Say this is equation 2. Now I am going to draw a mechanical system. Suppose this is a mechanical system. So I have to calculate the force for all these. Suppose K V force F. So we know that force F is equal to the total force. If I am applying the force in this direction, the force will be in this direction F1, force will be in this direction F2, and force will be in this direction F3. So force F is equal to F1 plus F2 plus F3. If I am applying a force in this direction, then displacement will also be in this direction. So what will be the value of F1, F2, F3? We can write this M d square x by dt square plus b dx by dt plus kx. or we can write this m dv by dt plus m dv by dt plus bv plus k integration of v dt. Say this is equation 3. Now we can draw a table for mechanical equivalent, electrical equivalent of mechanical system. So we can compare these three. Now we want to find the force electrical equivalent of mechanical system. So what will be the equivalent of force? So here I am drawing this force voltage analogy and force current analogy. So if I want to convert this force into voltage, if I want to convert this force into current, then what will be the exchange of values of mechanical elements, and by which value, by which element I will replace the mechanical element. So force is what are the elements? Mass, damping element, stiffness. So m, b, x, v, m, b, x, v and k. So we have to compare this differential equation with equation 1 and 2. What I am doing, I am comparing equation 1 to 3. So now we can see here mass is equivalent to the inductor L in case of voltage, and mass is equivalent to the capacitor in case of current. So I can write here MLC. I is equal d square q by dt. So q is equivalent to x. So I am writing here q is equivalent to x, and q is equivalent to phi in case of current. Now what will be the damping element? Damping element is B. This is dx by dt. So first order is replaced by, in case of voltage we can replace by R, and in case of current we can replace by 1 by R. So we can write here BR 1 by R. What will be the velocity, equivalent of velocity? Equivalent of velocity you can see here dV by dt. So this will give d square x by dt. V is nothing but I, and here V is nothing but voltage. V is nothing but I and V is nothing but voltage. And what will be the value of K? K is integral part. So you can see here K is the integral part. So K is equal to 1 by C in case of voltage, and 1 by L in case of current. So it will be equal to 1 by L in case of current and 1 by C in case of voltage. So this is the table for converting the mechanical system into electrical system. So by using this table we can convert the mechanical system into electrical system. Now I am coming to the method how will you convert this mechanical system into electrical system. The first step is that we have to follow the nodal analysis method, and after that we have to identify the number of nodes. So for identifying the number of nodes we have to see that how many displacements are there. So first we have to find the number of displacements, and that number of displacement will be equal to the number of nodes. Second step is that we have to take the additional node as a reference node, and we have to connect the mass or inertial element between the principal node and the reference node. After that, we will connect all the elements that are connected as it is in the network. So, we have to connect the spring and damping element between the principal, either between the principal node or between the principal node and the reference node, depending on their position. And after using these steps, we can get and we will obtain the nodal diagram, and after that we can write the differential equation at each node. After drawing the differential equation at each node, we can draw the electrical network by using simple method. So, this is all about for today. In the next lecture, I will continue with this topic. Thank you.